Hey guys, sorry I couldn't be there with you for this last day before Thanksgiving break. Um, let's see, to make up for it, I will literally come up with some Thanksgiving themed jokes right now. They will be bad. Um, how do you open a door? With a turkey. Let's see. What is black and white's favorite Thanksgiving food? Gravy. Ooh, that was rough. And then let's see. Oh, this is an old one. I'm not gonna make this one up. I know this one from a long time ago. What do you get when you divide a pumpkin's circumference by a pumpkin's diameter? Pumpkin pie. Oh, geometry jokes. Always killers. Whew, okay. Well, I'm sure you're gonna be much happier when I get on to just doing some work instead of telling bad jokes. So I think I'll just go through one of these problems with you guys. Since we all know the hardest problems are at the end of the worksheet, I will do number 8. So this should pretty much get an idea of what to do after that, but your job is to get the standard form function into vertex form, pull the vertex out, graph the parabola after that. So little things that we can tell right now about the graph. We've got a reflection, so this graph better open up upside down when we're done with it. We've got a vertical stretch, so we better have a skinny upside down graph. Apparently this graph did not go back for seconds. Oh, bonus joke. And we know that the y-intercept is at negative 68, so which really probably is not going to help us very much. So just going to have that, but not do anything with it. But we're going to go ahead and get this into vertex form first, but we're just going to keep that stuff in mind for later. Checks on our work. So first thing I want to do is to get that a value to be 1, and since it's negative 2, I'm going to divide everything by negative 2. And then, let's see, that gives me y over negative 2 equals x squared minus 12x plus 34. Let's see. And then we want to get rid of that 34. We want to create the space to put our perfect number. So y over negative 2 minus 34 equals x squared minus 12x. All right, so now we're going to actually complete the square, which means that we want to find the perfect number so that when we factor this right side, that it comes out to be a perfect square. So we do that by taking our new b value, so negative 12, dividing it by 2, and squaring it, which gives me negative 6 squared, which gives me 36. We take that 36 and we add it to that side. Now that side will factor perfectly. And take 36 and add to the left side also. And then on that left side, we go ahead and combine those like terms. We get y over negative 2 plus 2. And on the right side, we have x, and then minus 6. All right, so we have that number there for a little, make that easy jump to the factoring. But of course, you could have just asked yourself, what are my factors of 36 that add to be negative 12, and figure out that'd be negative 6 and negative 6. So now our job is to get the y over here by itself. So I'm going to get that 2 away. Gives me y over negative 2 equals x minus 6 squared minus 2. And then we want to get rid of that negative 2 on the bottom. So I'm going to multiply by negative 2. Also going to multiply the right side by negative 2. And again, distribute that into the parentheses here, and then in front of the parentheses here. Not my neatest of work. Let's see, so I guess y equals -2 over x minus 6 squared plus 4 now. Let's see, I guess we start off with the g of x. I'm going to go ahead and put g of x back on there. All right, so there's our vertex form, which means that we now know the vertex. And so remember that that inside guy is a liar, and so that's positive 6. Trust that one on the outside, so positive 6, 4 will be our vertex. The other thing I know right from that is that my axis of symmetry will be x equals 6. So that's that vertical line. The x is our mirror. So I'm going to go ahead and draw that in. Draw that in. So x equals 6. So the vertex was at 4 on there, so that'll be right there. So what else do I know? So we saw earlier that our y-intercept was at -68. Not too helpful, but it does kind of confirm that that graph is going to open down, since that would be well below our vertex. But so since I don't have any other free points, I'm going to have to go ahead and just find 2 points on the right or 2 points on the left of that vertex. And so I'd be looking at finding 7 or 8 or 4 or 5 on the left. Again, my just general habit is to plug in numbers on the right, but it doesn't actually matter which ones you do. Just don't go both sides. Kind of waste your time there. So g of 7, -2 times 7 minus 6 squared minus 4. Of course, 7 minus 6 is 1. 1 squared is 1. -2 times 1 is -2. So -2 plus 4, which is 2. So I got 7, 2. And then, let's see, let's get rid of this junk. So 7, 2. There, and then I can reflect that to the other side. And then I'm going to go ahead and find g of 8. Dang it. Always do that. G of 8. So -2 times 8 minus 6 squared plus 4. So 8 minus 6 is 2 times 2 squared is 4 times -2 would be -8. -8 plus 4 is -4. And so it gives me 8, -4. It should be down here. Go and reflect that. And we see a pretty good picture of our parabola right there. It should curve down, continue smoothly, should not bell out like that, should not go straight down, should not curve back in, but it should just continue to smoothly expand on both ends. So I believe that is the goal for all of these problems, and some of you will have more free information on that, but just kind of go back and double check what we thought was supposed to happen. It does open down. It's hard to tell since we don't have another parabola to compare it to, but this is a if you notice the way the points are moving, they are moving faster than they normally would as far as the way they're stretching down. And we can only imagine where our y-intercept is, but it does make sense since it does have a bit to go to the left still, that it would take a while. It'd be moving pretty fast by the time it gets down there, so that's at -68. So hopefully the rest of this is pretty easy and you have a wonderful holiday, free of bad jokes. But I know we're surprising the kids with a early winter holiday present for taking the Great Wolf Lodge, and so and Nola's super excited to go there since we went there like 2 years ago. So it'll be really fun to have her and all the boys there. So hope you guys have a safe and fun holiday, and I'll see you back on Monday.